A welcoming hand for Julia Christensen.
Hi, everybody. Thank you, Carrie. Yep, that's all true, and really glad to be here. So I'm going to tell you tonight about my ongoing project, Upgrade Available. A lot of times the way I work is I sort of get into a research project that unfolds over time and kind of manifests as a series of art projects along the way, and then winds up as a book in the end, which is kind of where I am now. But I will tell you now how I got from there to here. So, Upgrade Available. In 1977, a pair of spacecraft, the Voyager starships, set off to study Saturn, Jupiter, and their moons. The mission was designed by NASA's Jet Propulsion Laboratory in Pasadena, California. Each spacecraft was outfitted with a computer that operates on 68 kilobytes of memory. A rare alignment of the planets allowed the craft to use Jupiter's sheer gravity to slingshot out into the outer solar system, and the 5-year mission was extended to a 12-year mission. NASA was able to upload new software to the nimble onboard memory, and our Voyagers were able to study Uranus and Neptune. Well, they kept going. Now, 41 years later, the Voyager mission is the longest, farthest journey into outer space that humankind has ever initiated. The spacecraft, which were originally designed to last for a 5-year timescale, are still functioning. In 2012, Voyager 1 entered interstellar space beyond our solar system, and Voyager 2 is not far behind. Using their very efficient computers, the Voyagers send us aural vibrations that measure the density of interstellar plasma, the echoes of our solar system's magnetic field, and the decrescendo of our sun's wind far behind them. Meanwhile, here on planet Earth, an unexpected series of events in 2011 led me to a corporate e-waste processing facility outside of Chennai in the south of India. I was floored by what I saw there. 40 tons of electronic trash that had been imported within 2 weeks before my visit, most of it from the United States and Europe. I was faced with mountains of computers, cell phones, hard drives, DVD players, etc., heaving under the hot sun. I've been back to India 3 times in the context of this project to learn more about the formal and informal international e-waste recycling industries. These pictures are from Mustafabad in Delhi, the largest informal e-waste market in India. It's impossible to know how many kilobytes of memory we have buried by now on our own planet. We do know that the low-end model of the first iPhone, released in 2007, had 4 gigabytes of memory on board, and the iPhone has been upgraded 14 times to new versions with increasingly larger memory banks. And at least 1 billion iPhones have been sold since 2000. To put that into perspective, 4 gigabytes is 4 million kilobytes, or 58,824 times the memory on board each Voyager spaceship. Upgrade Available is my ongoing project investigating how upgrade culture, the perceived relentless need to upgrade our electronics and recordable media to remain relevant, impacts life on a range of scales. After that first trip to India, I realized that in order to understand more deeply the environmental crisis caused by technology, I needed to broaden my understanding of our complex relationships with electronics and recordable media. My projects over the last several years have investigated how we encode our electronics with our memory, our identity, and our legacy, creating very complicated pieces of trash. So, we begin our story at the smallest time scale. I call the short cycles of time between each of these upgrades of our software and our hardware technology time. When we're living on technology time, our public imagination is confined to the brief cycles of time between upgrades. When the upgrade is always available, it becomes difficult to plan for the long term, especially where technology is concerned. A piece I made about technology time is called Burnouts. This is a series of self-designed video projectors using discarded iPhones as the sole light source. I used lenses and mirrors stripped from overhead projectors, and the projector cases are 3D printed. This juxtaposition of new and old technology illuminates these short cycles of technology time. It won't be long before the cutting-edge 3D printing technology used here is as outdated as those lenses and mirrors. Here's the 3D design of the video projector, which I had fabricated at a factory in Cleveland, or Avon near Cleveland, the factory that makes Vitamix blenders, incidentally. They have a 3D printer with a 6-foot print envelope, and these are 21 inches by 7 by 7. The iPhones project constellations on the gallery ceiling that have been retired from official star maps. Every now and then, the International Astronomical Union deems certain constellations no longer relevant to the study of the night sky, usually due to light pollution. I worked with the planetary staff at Oberlin College, where I teach, to dig through old star maps to figure out where these constellations once were to make the animations. So to be clear, the stars are still there. We've just left them off of the map because they are no longer relevant to us. The mappers have changed, not the map. This is an example of obsolescence as a cultural decision. Here are the phones displaying the animations. So I chose constellations from the list of retired constellations that had been named for technological inventions: the sundial, the hot air balloon, the print shop, the electric generator, and Herschel's telescope. I thought it was a fitting homage to project the retired constellations with the retired iPhones, which are also still working just fine, though they too have been deemed irrelevant. So we experience many cycles of technology time over the course of our lifetimes, all the while encoding our electronics with our memory, identity, and our legacy. In 2018, it was announced that over 1 billion people use Instagram. As of 2016, there were 95 million posts of images every day, stored on thousands of computers and server farms around the world. Need I remind you, the cloud is not actually a cloud. It's made of computers that are just not on our desks. In order to put into perspective the amount, sorry, I keep losing my cursor here, man. There it is. So, in order to put into perspective the amount of material space used to store our images, I began to look at how we stored our images pre-internet. This is a series of photographs called hard copy, portraits of media collections that will never be accessed again due to obsolescence. And yet the people who made these recordings just can't seem to let go of them. We all have that old box of old VHS tapes or zip disks in a closet, a kind of appendage we can't cut off, an extension of our identity. So on one hand, there's this shared cultural anxiety about the loss of the hard copy. I personally have taken thousands of pictures of my children, which are scattered across hard drives, computers, and yes, clouds, but I have very few printed out. On the other hand, we might be moving away from the practice of storing images at all as technology like Snapchat becomes more prominent, apps that allow us to share our images and then they disappear in 24 hours, leading me to question if the sharing of images was always more important than the saving of images. In 2013, I stumbled onto the phenomena of people selling the slide collections of recently deceased family members on eBay. I began collecting these collections. Throughout their lifetimes, people meticulously stored these memories, but when they died, their loved ones didn't understand the value of the images, who these people were, and they sold them for next to nothing on our online marketplace, rendering them practically worthless, anonymous, disposing of them into the ephemeral domain of old vernacular photography. The images are gorgeous, such care for composition and the decisive moment when there were only a few shots on a roll. When these slides are seen alongside the hum of a slide projector, you can just imagine people gathered around the machine in the living room of yore, sharing the stories from vacations or parades. In these days of liking the images of strangers on social media, we're used to the idea of sharing our pictures with a dispersed geographic audience. But these images were meant to be shared only with people in one location, a specific audience, leaving me feeling like I was viewing images that I was not supposed to see. I digitized thousands of these images, which could potentially be seen as upgrading the image. But considering the glory of the original slide photograph projected with that translucent 35mm glow, obviously something is lost as they are flattened to the digital plane. Meanwhile, my parents gave me their slide collections, and I thought this was something different. But I realized the images are a part of the same plane of lost photographs as the collections of the strangers. Here's my mom at the Eiffel Tower in 1969. Going through all the slides, I realized that there were similarities across the collections, photos that everybody seemed to take. I began to pull out triptychs of images that told the same story, a shared narrative. These are the memes of the 35mm slide. In each triptych, I included 2 images from the slide collections of strangers and 1 from my family slides, reminding us that although these images are all part of the same plane of forgotten vernacular photography, all of the images were important once to someone, once upon a time. So the irony is, even though we usually think of digitizing as upgrading the image, creating a more lasting legacy, archival ink and paper is still perhaps the most stable way to store these images. The slide and eventually the JPEG file will be obsolete. So digitally, I created line drawings of the humans in the slides of these triptychs that I had selected and removed all the contextual information, rendering the images anonymous. I then made actual drawings of them using ink and paper. I decided to use a digital plotter to draw the images, essentially a vinyl cutter, and I swapped out the blade with the marker. So using a robotic arm to make these images flattens the digital narrative even further. The line drawings almost treat the images as data. The series of images is called We Share Our Pictures. So here's my dad on the same trip with a rental car in Amsterdam. He still talks about this car. And here's the drawing. My dad was not the only one to take a picture with his car. This triptych of drawings is called We Want to Show You Our Cars. This is called We Saw the Large Monuments. We posed before vistas. So there are 30 images in this series, and they're rather large, 30 by 22 inches. Here's 3 of the triptychs, which were recently installed at the Los Angeles County Museum of Art. And speaking of LACMA, that brings us to institutional time. So since 2017, I've been a fellow at the LACMA Art and Tech Lab. You can see how savvy I am with technology with this cursor business. So sorry, guys. Such an odd. It's just, there we go. Okay. LACMA, institutional time. So the LACMA Art and Tech Fellowship is given to a few artists every year. The program's a reboot of the LACMA Art and Tech Lab of the 60s, which partnered artists such as Warhol, Turrell, and Rauschenberg with tech companies, scientists from tech companies like IBM and Xerox. So the program introduces artists to scientists at large tech corporations of today, including Google, SpaceX, and DreamWorks, etc. So since I've been working there, I've had the opportunity to look at how these issues of the upgrade impact an institution like LACMA. I've worked extensively with the institutional archives at LACMA, which exist in every imaginable media format. How can an institution commit to the cost, time, and energy of upgrading materials when another upgrade is always impending? I was able to take this box, full of this media with me to this place, the Media Archaeology Lab at the University of Colorado in Boulder. Over 100 computers and their operating systems developed since the 1970s are housed here, and they're all functioning. And they all have media specific to those machines. It's totally open to the public, so people can go there and work with these old computer systems. So I took this box of ephemera from LACMA to the mall, as it's called, to attempt to upgrade obsolete files from floppy disks and zip disks, which took a lot of time, a lot of cords, and actually made very little difference from version to version. The PowerPoints from 1995 still look pretty much the same when I was finally able to get them into a more contemporary machine. But in the meantime, I ran into a lot of screens that looked like this. The disk is unreadable. Do you want to initialize it? Over and over. So as I said, how can an institution commit to upgrading all of this stuff given the problems of doing so? And how can an institution meant to transmit cultural artifacts across the span of multiple lifetimes square itself with technology time? As technological systems continually upgrade, how can museums and universities create systems flexible enough to store, preserve, and transmit electronic information beyond our own lifetimes as technology time constantly renders the past unreadable? And what about institutional buildings? Buildings, as we currently conceive of them, have a very difficult time keeping pace with the fluid rate of technological upgrades that we've come to know. How can walls, ceilings, and floors possibly keep up with the endless updating of plugs, ports, and cords that has come to exemplify the 21st century? We need liquid walls. Maybe buildings have become obsolete. With the impending upgrade of the LACMA museum site, they are planning to raise most of the existing campus to build new museum buildings, a site designed by architect Peter Zumthor. It seemed like a poignant moment to look at museum infrastructure as a way of understanding what the museum of the future might look like. How can a museum building support museum operations and art exhibitions reflecting upgrade culture? It's always helpful to begin by looking at the past. At LACMA, I've been photographing obsolete technology that is embedded in the current building site as a way of looking forward, to think about how technology will be supported on the future building site. So this is a robot sensor, of which there are several in the walls of the galleries at LACMA. If you're over there, you can look up and see these. Here's the robot. It was employed by the security staff briefly in the 90s until it ran into a pedestal, and then that was that. But the infrastructure that they had put into place for these robots to sort of sense where the wall was costly enough that it just made sense to leave them there. So you can find those on your next trip to LACMA. Here is a handful of antennas and discs and servers on a rooftop that are not in use. This might look familiar to some, a phone booth with no phone in it. And here's a Wi-Fi port out by Chris Burden's Urban Lights installation that hasn't been working for at least 10 years. So these photographs were recently exhibited at LACMA too, a series that I call Technology Time. So through my fellowship at LACMA, I was introduced to someone at NASA's Jet Propulsion Laboratory in Pasadena. So after a discussion about how upgrade culture impacts future-reaching research, like the development of spacecraft for long-range space travel, this person told me that I needed to talk to Dr. Anthony Freeman. So a meeting was arranged, and I met Tony, as he's called, who's the director of the Jet Propulsion Lab's Innovation Foundry, an arm of JPL that focuses on the ideation and conceptualization of mission proposals. So most everything at JPL starts here, from the Voyagers to Mars rovers to space shuttles. When I met Tony, he told me about a spacecraft concept that he's working on, which is meant to travel to Proxima B, an exoplanet in the Alpha Centauri system. So that's the next star over, the closest star to our star, the sun, 4.2 light years from Earth. The idea is that this spacecraft will leave Earth in the year 2069, at which time we will be able to reach 1/10 of the speed of light, meaning it will take over 40 years for this spacecraft to reach Proxima B, arriving round about the year 2109. So this spacecraft will need to upgrade itself autonomously on its own 6 times throughout the course of the mission in order to survive the environmental conditions of this interstellar journey. But it will also have to upgrade itself to remain relevant to life on Earth when it arrives at its destination. Because here, things are going to keep changing. So when it sends us back data, we have to be able to read it. So, welcome to space time. So how do we transcend technology time, our human lifetimes, institutional time, to create technology that's meant to last beyond any of those cycles? After several meetings and conversations about my work about upgrade culture, Tony invited me to envision an art project to be embedded on this interstellar craft, reflecting its characteristics: time, speculation, transformational technology, and the future. How can an art project on a spaceship apply what I've learned about the cycles of technological progress and obsolescence? How can we make something for the ages that can describe a story about life on Earth while being flexible enough to change, to learn, to adapt as we do? Since those are characteristics embedded in this spacecraft, how can the art and science merge so they reflect each other? Our interstellar project is meant to be a spiritual successor to the Golden Record Project, a record of sounds and images which is adhered to the outside of those Voyager crafts that were launched in 1977. It was produced by Carl Sagan, Annie Druyan, Timothy Ferris, and others. So I want the piece to be inspired by the Golden Record, but not iterative of it. The Golden Records have an inherent problem with representation. How can any one person or any one group of people choose a series of sounds and images actually meant to represent life on Earth? How can we make it clear that while our artwork reflects life on Earth, it isn't the only story? So at JPL, whenever they begin to develop a new mission project, they hold a meeting called the A-Team. So this stands for the Advanced Architecture Studies. So the idea is they pull together experts from a range of fields and have this day-long brainstorming session. So Tony thought we should have an A-Team study for this art project. We included experts from a range of fields: robotics, AI, exoplanetary science, mission systems, aerospace engineering, etc. So in this 10-hour day, we blew the ideas wide open. We discussed everything from radio waves to light waves to holograms to robots, and really talked about how this this piece can kind of transcend the material culture of the upgrade. So since that day, we've convened 4 additional A-team meetings. I've spent a lot of time in a room with these really visionary scientists with the intention of developing this spacecraft. But also now we're talking about developing a spacecraft that we can launch now, within the next 2 to 3 years, that will inform the very far future Proxima B mission. So we've worked through the challenges that we need to overcome in order to get to that Proxima B mission, which include propulsion, of course, which I will be no help in figuring out. Artificial intelligence, communication issues, how do we communicate with the thing over time, and upgrade issues. And also, how do we keep the public interested, in this long period of time that craft will take for its journey? How do we get people to care about this long-term project? So we realized that longevity is really a big challenge that we need to address, and that is something that we can begin to address now. So back to thinking on in terms of space-time and planetary time. We need to transcend these short time cycles. Scientists will retire, hard drives will break, USB inputs will become obsolete, and generations of humans will come and go during the time of our Proxima B mission. But who will be alive from start to finish? There are species on Earth that do live long enough to see the beginning and the end of our Proxima B mission. Whales, coral, and even some kinds of fish live for centuries. This is maybe my favorite slide in the whole talk. So this led me to the idea of potentially sending a message out into the cosmos on behalf of another species that will live for the entirety of the mission, a species that does actually live on planetary time. Trees. So here are 4 trees that are between 4,000 and 5,000 years old. So we have decided to select a network of trees whose story can represent long-term shifts on our planet. The health of the tree tells this long story about planetary conditions, changes, shifts, etc. Not just in the life of the tree, but in the very ecosystem that we are also a part of. So there are these little spacecrafts called CubeSats that are deployable now. They're about the size of a toaster. And usually they're deployed to work for 3 to 6 month missions. So we are asking, can we create a spacecraft that can live as long as our tree? How can the health of the spacecraft over the long term tell us more about how our technology survives in space? So we figured out that we could augment a tree in order to harness its electrical properties, its electrical charge, to use it as an antenna, a receiver and a transmitter. So we're going to collect data on site at the tree about its health and experience. Simultaneously, we'll collect data on the CubeSat about its experience in space. We're going to translate those data streams into sonic frequencies. So as this CubeSat orbits around planet Earth, the tree and the CubeSat will sing to each other for 200 years. So we're building this project to last for 200 years. So this will be a 200-year duet. Effectively, the tree and the spacecraft will sing to each other about their experience, their shifts, and their stories over centuries. So we're planning to have speakers and displays at the tree site so people can, explore this in the public sphere. The sound files, the songs, will be available online in real time, public, open source, so that people can mix, sample, and interpret the data songs from the tree and the spacecraft. And meanwhile, here on Earth, we'll keep a hard copy record, perhaps at LACMA or at another museum. And each year will inscribe the aggregate of that year's sound file in concentric circles, much like a tree ring, or perhaps like a golden record. But this time, the record we are making is bigger than us. It's not about humans, but about our participation in this ecosystem that includes species that live longer than us, trees and others, and the very technology that we build, like this spacecraft. So here I am taking a selfie, speaking of contemporary storytelling, in the reflection of the original Golden Record cast at JPL. It's so powerful to see this record and imagine the other copies of it hurtling through interstellar space, the furthest piece of technology humans have ever created, ready to be discovered by our as of yet unknown cosmic neighbors. Which makes me think about the other audience for all of this space artwork, us, here on Earth now. These works about the great expanse of time, space, and our place in it inspire us because it takes real hope to envision our species, our technology, our stories in the context of the very long-term future. Thinking about a potential upgrade to an interplanetary existence reminds us too that we are already a cosmic species in outer space. And actually, Earth is our dream planet. These trees, this rain, this sun, this dirt, these microbes, so far we have never, ever observed anything remotely like it. So while we envision art and technology for space-time to last longer than our lives or our institutions, we must not forget how crucial it is that we overcome the earthly problems of technology time. Thank you.